So, oops, here again. And today we would like to talk about migration to multi-tenant. So if you wonder about that picture, actually, if you ever visit Munich, where I'm based at, that is actually in Munich, in the city. So if you are a surfer, you can bring your board because there's I wouldn't even call it a river, but it's called Eisbach. And they put some bowls into that and have a steady wave. So it's in the city center actually, and it's funny because in the winter sometimes you can see people with a surfboard on their bicycle going there because there's no parking space in this area. So pretty neat actually. So just this as a start here, and now let me take off. I'm Mike. Oops, my video went off for whatever reason. So video's back again. I'm Mike. I'm the product manager for database upgrades and migrations at Oracle for quite a long time. I do this since 14 years now, and I work with customers in the field, and I also test a lot. I write a lot of stuff on the blog. So if you want the slides and much more, go to the upgrade blog. MikeDietrich.de.com is the blog's address, and the same name is my Twitter handle. So if you ever wondered about the DE, that is the internal Oracle code for Deutschland, for Germany. So Mike Dietrich was taken already, so I had to go for an alternative. My Twitter handle, it's really safe to follow me on Twitter. I use Twitter only for technical stuff, never for food pictures, or even worse these days, for politics. And my LinkedIn handle, Mike Dietrich, very easy to remember that. What's going on here with the, let's do it like this. Oops. So let's start very briefly, and I did this yesterday as well, but I can't assume that everybody who was in the session about patching yesterday is in here today too. I would like to give a very brief introduction to release strategy, then a very, very short part about upgrade to 19C, and then we go to multi-tenant. So first of all, let us start here with the lifetime support policy, because that is really the driver why you're gonna upgrade. You typically don't wake up in the morning and say, oh my God, it's a beautiful day, let's upgrade and let's migrate to multi-tenant. So one of the most important parts is really when the Premier support ends for release, black bar, then we have a period called extended support, and then it turns red, and it turns red because it's extra cost. So in the first year, 10% of your support fee, in the following years, each year, 20%. And if it's gray here on the slide, like light gray, and it says waived extended, that means we didn't charge you. We just made it available for everybody. No extra task was necessary. That ran out for 11.204, end of 2018, so quite a while ago. And as you see, 11.204 goes even out of extended support at the end of this year. So in like 12 weeks, 11 weeks, 10 weeks, something like that, it's over. Then you can still get an extra called market-driven support. Has the same price tag as extended support, but is only applicable for severity 1 bugs and for security fixes. If you're on 12.102, you are already in paid extended support, and there's no such offering as of now for market-driven support, maybe later, but not now. And the question is, when you are already on 12.2 or when you are intending to go there, to which 12.2 release should you go to? 12.201, 18, or 19? And before I give you a recommendation, let me explain this here, because this is very important for the future as well for all of you. 19C is a long-term support release. And that means 19C is supported in Premier support. This is the black bar here, for at least 5 years. And then it adds also 3 years of extended support minimum. But now we made an adjustment for the future releases. We said everything after 19C is called a short-term support release, we said initially, but now we call it an innovation release. An innovation release means we deliver a lot of new features, but we give a very short period of support. So 2 years maximum and no extended support. That means everything after 19C you would go to, be aware that you have to upgrade quickly after, or you give it to your developers to use new functionality like blockchain tables, for instance. But your production estate will really move forward from long-term to long-term support release. So from 19C to whatever will be the next long-term support release. And therefore, a clear recommendation, if you haven't upgraded yet, go to 19C. If you are already in, let's say, 12.201, we realized that we didn't communicate the release numbering so well, so we added a no extra cost extra, which is called limited error correction support to 12.201. So for all of you who are now at 12.201 and thought, okay, this is the final 12.2 release and whatever, and 18 and 19 is something new, or where your software vendor was just tricked by our communication here, 18 is 12.202 and 19 is 12.203. But as a lot of people are on 12.201 still these days, we said, hey, we add 1.5 years of limited error correction support, no extra cost for you, nothing to do for you, you just have that. We release severity 1 fixes, security fixes, and very important, we release also the release updates quarterly. And if you have a merge patch, an important one, you get this on top of a release update, even in like October 2021, in a year from now on. So keep that in mind, but everybody should go to 19C. That is the release to go to. So this was a very short introduction into release strategy and where you should upgrade or migrate to. Now, very briefly, because we need this later on for multi-tenant, upgrade to 19C. And in order to do a successful database upgrade to 19C, it's very simple. You download the software for you, unless you are in the cloud, is always 19.3.0. So you take 19.3.0 from eDelivery or from the Oracle.com webpage, and then you download the most recent release update. That is right now 19.8, but next Tuesday it will be 19.9 because 20th of October is the next patch day. So then you have 19.3 and 19.8 or 19.9. Yesterday in a patching seminar, I showed how you can apply everything in one pass. And then you need the newest auto upgrade. And the newest auto upgrade, you need that because the auto upgrade, even you will get with the October RU next week, the one you get from this Oracle support node under the 0.3 in my slide, is newer because we refresh it every 6 to 8 weeks right now. And as we had a code freeze, the day when 19.9 becomes available, we may release also a newer version of auto upgrade already, which is not in 19.9 packaged. The one is good, you'll get, but the one we make available via this MOS node has a bit more fixes, extensions. And the last part is, once you have upgraded, you do everything necessary for performance stability, like you do AWR diff reports, you use SQL plan management to nail down your plans. Maybe you have a license for real application testing and you use SQL performance analyzer, or for instance, also capture replay. So all that for a successful database upgrade. And when you go to the blog and the videos, you find also that for each of these pieces, we have a separate webinar. So auto upgrade is the recommended way, and I say it's the only recommended way to upgrade your databases. And you download auto upgrade from this MOS node. Very important, when you scroll down in a MOS node, you find also the previous versions of auto upgrade, just in case if we put in a new problem we haven't found during our regression testing and you need a previous version. But even more important, there's a very transparent changelog, and it's not a changelog for the node, it's the changelog for auto upgrade. So we clearly and transparently tell you all the bugs we fixed in auto upgrade, nothing hidden there. And we give you also advice if we included new features. Like pretty soon, yesterday in the other EMEA webinar, my colleague Daniel and I did yesterday morning, we got asked by a lot of people when we support our data guard completely in terms of everything handled automatically. Hopefully the next version of auto upgrade does that for you. And what does auto upgrade do? I will show you this when we go to multi-tenant, because it interacts with multi-tenant here. So the migration to multi-tenant and auto upgrade to 19C, how does this interact? How does this go together? But before I show you that, first of all, a quick flashback. because I think since 12.101 or 12.102, we had this sentence in the upgrade guide, the deprecation of the non-CDB architecture. And it said the non-CDB architecture is deprecated in 12c. So deprecated means we don't develop something further. And it may be desupported. Oh, okay. And this is critical, unavailable in a release after 12.2. So what the fine print didn't say here with 12.2, we meant 12.2.1, 18, 19. So until Oracle 19c, everything is as you knew it for decades. You don't have to go to the CDB architecture yet, even though I would recommend it. And I think the reason why you're in this session today is you're interested or you did it already. So we talk about this in this 1 hour, 20 minutes, something like that. We recommend the CDB architecture. I recommend that as well for several reasons, but you don't have to. So don't feel forced, don't feel pushed. You will stay a long while on 19C for sure, and you don't have to. But I think it's always a good idea to start early with some things. First of all, you learn a lot of new stuff. And second, when the cut comes, then you know it already. And then you are very well prepared. So this is the goal here. And the reason why you may consider with 19C multi-tenant already, there's no secret. The multi-tenancy license is not cheap. It isn't. But we included, and thanks to my boss, Roy Swanger, who pushed really hard for that, we included with 19C, from 19C on, not with 18, not with 12.201, free user-created PDBs in every Oracle license. So you see it on the slide here, even standard edition allows you to have free user-created PDBs. And user-created means the PDB dollar seed, which is always there, does not count here. But I give you more insights in the seminar here. That's why we are here, I guess. So free PDBs, that is one of the big pushes to say, okay, let's go to 19C and let's try this out. Why am I talking not about 20C or 21C today? First of all, after 19C, and you can see this already today because the 20C documentation, which 20C is available in the cloud only right now, the 20C documentation tells you behavior changes for 20C upgrade planning. And here I made a red box around it. Starting with 20C, Oracle database is only supported using the multi-tenant architecture. So after 19C, you can't even create a non-CDB anymore. So there you have to do it. And that's why I give you a clear recommendation with 19C, start playing with that, get experience. And let's say you go to whatever the next long-term support release is, then you have everything adjusted, your scripts run, your backup strategy, you have enough experience. So this is why we are here today. Now, how does auto upgrade interact here and what does auto upgrade has to do with multi-tenant? Of course, auto upgrade can upgrade a multi-tenant environment, but if you don't have multi-tenant environments yet, this could be 11.204, 12.102, 12.201, or 18C databases, and you download the auto upgrade from this Oracle support node, it's just 2 MB in size. Then you create, and this is your task right now, you create one config file, and this config file can cover all your databases if it needs to. So you just differ between what has to be done for database A, B, and C. When you never touched it, when we sit down in 5 minutes, you do your first upgrade completely unattended because you push the button and auto upgrade upgrades. Ideally to 19C, that is my clear recommendation, but it could also upgrade your database to 12.201 or 18, at least with the January 2019 bundle patches, release updates. So 18.5 or newer, 12.201 with January 2019. But clear recommendation, go to 19C. But auto upgrade can do more. If you pre-created a CDB, auto upgrade can plug in your databases afterwards right away. So you don't have to do that. And this means you can take your entire database as state and you can tell, oh, database A, you go into this CDB, database B, you go into that CDB. Of course, it's fully transparent. I don't like black boxes where a vendor tells you, oh, it does everything right. I want to see what's going on in case something fails. So you have the control on the front end where you have a job console, which allows you also to abort, resume, or restore, and of course monitoring. But auto upgrade writes a lot of log files. So the log tree gives you all access you need to the regular upgrade logs, also to the plugin logs. We have subdirectories for all steps. And if anything goes wrong, auto upgrade has a -zip command, and it puts all your log files into a zip file, and you upload this to my Oracle support. And then we have everything we need to diagnose what has gone wrong in case something went wrong. We have customers like I was so happy last week. I received email from a German automotive company, and they upgraded more than 500 databases in 10 days, completely unattended, because they scripted auto upgrade into their OS patching, which happens quarterly, and added auto upgrade, and more than 500 databases in 10 days. And only 5 issues were caught, but nothing of them had to do with auto upgrade actually. So this is pretty awesome. And we have more stories in the auto upgrade slide deck from customers, but auto upgrade itself is not our topic for today. The thing why I have auto upgrade here is you can in first step upgrade, then you plug in, and then we migrate the future PDB into multi-tenant. And this is, I call it a one command orchestration, because you basically just kick off and that's it. And an hour and a half later, everything is migrated. So this is the idea here. A secret, which is not in the documentation yet. If you have a 19C database already and you would like to migrate it, you can even use auto upgrade. And the term auto upgrade is a bit misleading because you don't do an upgrade here anymore. But when you tell auto upgrade, this is the config file, and you have source and target home are the same homes here on the server, and you tell auto upgrade, my target CDB is the CDB you have there on this server already, and you can rename your PDB if you want to. Target PDB name here should be PDB1, because right now my database is called DB12. It should be renamed to PDB1, and then auto upgrade, even though you don't do an upgrade, will plug in into that CDB and run all the necessary steps for you. So you can even automate that task completely with auto upgrade if you need to. And of course, with different databases, you can direct them also into different CDBs if you need to. Actually, as I received exactly that question from a customer just 2 hours ago, I will try to put this on a blog this week as well and show you how you can direct your PDBs into different CDBs if you need to. And if you need to drill down a bit more, because I won't show you a demo here, but on our YouTube channel, you go to the blog and videos, then I put in like 17 minutes. That sounds very long, but I give a lot of explanations before about how to upgrade and plug in into a CDB. When under the video in the comment section, you find the contents. And if you, because you listen to the slides already, you don't have to take them again unless you really enjoy them so much, but you can go directly into demo if you want to and skip the slide and explanation part at the beginning. So for the migration to multi-tenant, we have added parameters to the auto upgrade log. So the first one is you define into which CDB you like your PDB be plugged in. So it's a non-CDB, it will become a PDB and you want to plug it in. So target CDB, you need to create that. Auto upgrade doesn't create it for you. Then you can rename the PDB as I showed you before, target PDB name. You don't have to, this is optional. And the last one is optional as well, because by default, we use no copy, meaning the PDB stays in place. But if you say, oh, this is insecure and I want the fallback, then you use the target PDB copy option. And on the blog, you find also a lot of explanations how to deal with this parameter. And I see that the second equation mark is missing. So after file name convert, there should be an equal and then the dashes and brackets. So now let's drill into multi-tenant. And what is multi-tenant? After I explained to you that auto upgrade can easily migrate into multi-tenant. And first of all, in 19C, You can have free deployments. You can have on the left side of the slide non-CDBs. Same as before. No change to previous releases. The middle pillar, free tenants. This is no extra license with 19C only. Not with 18, not with 12.2. Available also for standard edition. And the PDB $seed, which is here marked in gray, does not count. Very important hint, if you do that, if this is your license agreement, then set always max underscore PDBs free. Because this way you prevent an accidental local cloning or somebody just plugging in another one. Because as soon as you would plug in the fourth one, and this is not prevented otherwise, the license counter for multi-tenant would count up. And I don't want to bring you in like license trouble. So here we have a good workaround. You can prevent this easily. Max PDBs free and no license violation. On the right side of the slide, multi-tenant, there's a license required. Yes, with standard edition, not optional, but only with enterprise edition possible as usual with extra licenses, or in most cases. You can have 252 PDBs, which I think is quite a lot. In the cloud and on Exadata, you can even have 4,000 PDBs. I give the recommendation, let us do that if we want to, but for you, 4,000 PDBs, even though it's theoretical possible, and we do this in our cloud deployments in Autonomous, but I wouldn't recommend this to you. So based on customer experience, 50 PDBs in a production environment and 150 PDBs in a test dev Q&A environment, that's, I would say, are the maximum I would go up to. Otherwise, some things get really a bit like, The multi-tenant concept. Here you see 3 PDBs. They can be even on different versions or patch levels. So at first, I create a new PDB. And a new PDB will be provisioned as a clone of the seed. This is the reason why the seed is there, and the seed is read-only always. And there are very rare occasions when you are allowed to change the seed. But you can also take a non-CDB and make it a PDB. A conversion step is necessary, as I showed you. Auto upgrade can do this for you. But I can also do remote cloning, or I can unplug and plug into a different one, which can even have different patch levels. And to make the patching, the data patch part really smooth and flawless, we included the SQL and PL SQL part of a patch into a view inside the PDB. So the PDB carries the necessary scripts with it internally in order to do switches if you go to a lower patch level, especially. Let's say we go from 19.8 to 19.7, then we would carry this with us. I can also clone here remotely. I can unplug, archive, whatever. So the idea is data is isolated in the pods, and we can have a lot of flexibility with them. The other idea is we virtualize on a database server. So when you check now on your operating system, this environment, you see only a CDB, a SID for this CDB. You don't see anything about the existence of these free pluggable databases on your OS. That means your applications on the left side here, the applications need to connect via the service name. I show you also other ways to connect, but ideally it goes via the service name. And for our CDB and our PDBs, we share the resources. So we have one SGA, we have one set of background processes, we share the redo logs, we share the flashback logs, the control files, and the SP file as well. So you can set parameters for a PDB, but they are then not stored in the SP file. They are stored in VDOLA system parameters, I think, inside each PDB. So resource sharing, we can use the resources much better. That's the idea here. And when you would like to connect, the easiest thing is you do a /assystdba. And a /assystdba by default will bring you into the CDB $root. This is the black brick on my slide. When you would like to connect into a PDB, I told you need to specify the service name. So first example here, SQL plus sys/password at service name. You can also use the Easy Connect, and the Easy Connect is so easy. I never remember it, so that's why I put it on the slide. There's also a hack which I personally don't like. You can export a two-task variable and then still connect with the username and password. I'm not a fan of the two-task variable. When I started with Oracle, there were a lot of issues in Oracle 7.3 with customers who set two-task. I still remember that in my brain, so I have a natural allergy developed against setting two-task anywhere. Switching between containers, that means you say all the sessions that container PDB1 or PDB2, or all the sessions that container $root. So this is how you flip inside back and forth. Yeah, you may wonder, but how can I go directly into the PDB without all this hassle? And for this purpose, we introduced an environment variable with 18.5. And I bet with you this came in because I think it's still not in the Oracle documentation, but you find it in MOS. It came in for eBusiness Suite, I guess. eBusiness Suite 19c has to be a pluggable database, and I guess they brought this in for some tool working with EBS. So you set export Oracle PDB SID, PDB1 in my case, and then you can do a SQL Plus as sysdba, and you connect directly into your PDB. I show you this in a quick demo. So export Oracle PDB SID equals, in my case here, PDB FTX, SQL Plus / sysdba, and let's show con name, the container name, PDB FTX. So I'm in, I connected directly. This looks at first sight absolutely cool, absolutely thrilling, but it has two really big major flaws. One flaw is, if I would have said Oracle PDB SID equals Mike, it would have still connected me without any error, but I would be in the $CDB root. Because internally, this is handled with a very simple mechanism. It's a database trigger, system trigger. So when the system trigger gets a connect where this environment variable is set, it tries to connect you directly with an alter session set container equals that PDB you defined in this environment variable. Very simple. Problem is, a trigger can't give you output on the screen. So the trigger connects you anyways when you do a SQL Plus / sysdba, no matter what you set in this environment variable, but at worst case, you're in your root container. And this is not so cool because it actually happened in my hands-on lab already that I started something which I thought I start in the PDB, but actually I started in a root container, which was not so cool in this environment. In my hands-on lab, it doesn't matter because I flash back, but in the real world, you may wonder, are there any limitations? Is there a question? No, there are no limitations. So be aware of that. Another thing which came up very early in the resource cycle, in the release cycle, is actually I asked that as well. Can I decide my PDB gets only this amount of the SGA because now 20 PDBs share the SGA? Can I decide that? And with 12.2 you can. So you can set SGA min size, you can set max IOPS, max megabyte per second, and you can do also instance caching by defining the CPU cores per PDB. You can set this on a PDB level, and by default the resource manager is active, does that for you. That looks great at first sight, but there's also, again, a fine print. And I think this is the case why you came to this session today, to hear about such things which are not obvious in the documentation. You can easily over-provision without getting any error messages. So let's assume you have an SGA of 10 gigabytes, and now you plug in 10 PDBs. And instead of having a gigabyte for each PDB by default, in theory, you define all your 10 PDBs with 2 gigabytes of SGA min size. Now you would assume I plug in 5 and then it should give me an error, maybe? No, it doesn't. You can plug in all 10 of them. Now you ask for 20 gigabytes, but you have only 10. So the resource manager silently in the background acts now as a judge and decides, oh, you get this, you get that, without giving you any error messages. So be aware of that. Don't over drill this, and don't do it uh, too deep. Actually, I'm a fan of letting things here go unless we have really a need for doing things. Otherwise, you have so many parameters set, and then you plug out and plug in, and then things are differently, and you don't know what you get at the end. So be sensitive to use too many of these parameters. Oops. Another thing which really hit me a lot, and it cost me 3.5 years of discussion with the multi-tenant team until they changed it. At the beginning, when they introduced multi-tenant, they said all components have to be there, everywhere, which is an easy solution because then you don't have any problems afterwards. But customers didn't like that idea, mostly for license issues, but also for patching topics. So with 12.2, you can easily decide which options, which components should be there. If you wanted to do it in 12.1, you had to go the way via the database creation scripts. So you only will see the option to decide which components are there when you go in the DBCA into advanced configuration and then custom database. This is really important because you will not see the next screen if you do like data warehouse or OLTP, or if you don't go to advanced. And in the next screen you see then you can decide which options should be there. And the first thing to take care here is you have choices to say include in the select component and include in PDBs. And what does that mean? First of all, this include in PDBs means if, in my example, I have Java, text, multimedia, OLAP, spatial, and Apex in the root container, I wouldn't have it if I click now forward this way. I wouldn't have it in the PDB$seed. That means whenever I provision now a new PDB, that PDB has nothing else than the Oracle server and XML or XDB. XDB it is. So be careful. If you want it in a PDB$seed, you have to make sure there are marks here include in PDB as well. And the other thing, this slide, intentionally I did something very, very wrong here. I had Apex in the root container. And this was the default in 12.1. And Apex should never be in the root container. And with 12.2 by default, we changed that. And the Apex team is pretty transparent and understood quickly what the problem is. Because when you have Apex in the root container, then you have Apex in the seed just as a, like only the corpse, not the entire human being. So Apex is like a limited part in a PDB when it's in the root container. Now let's say you have Apex 18 and you unplug and you plug into a CDB which has Apex 19 in the root container, then you need to upgrade Apex. Okay, that is the easy case. But what happens if you plug into a CDB which has no Apex in the root container? Then you can't plug in because that part of Apex which lives in the PDB can't live alone. So you have to go back, export your applications, do everything right. Bad idea. Apex has to be in the PDB only, and then you can even mix Apex versions. So PDB1 can have Apex 18 and PDB2 can have Apex 19, and PDB3 has Apex 20C, which is available already, I think. So be aware, Apex never in the root container. If you want to remove components, this is not documented for multi-tenant in a lot of cases, unfortunately, because at the beginning when multi-tenant got introduced, all components should be there. So the components owners didn't write specific scripts how to rip it off multi-tenant. I put some advice on the upgrade blog, and over time, more and more MOS nodes came up, which explained also how to remove certain things for a multi-tenant environment. For instance, the Java I referred to yesterday, there's a clear note explaining how to remove JVM and dependent components from multi-tenant environments correctly. Then you need to be aware, and this is one of the reasons why I recommend customers start with multi-tenant early enough. You need to deal with cut-con-PL. And at the beginning, I call it like a forced marriage, a forced wedding. where somebody decided you have to marry that person. And at the beginning, you sit there and say, oh, really? And after a while, you say, it's not so bad. And after a while, after you say, oh, wow, this is great. So it works like that. So at the beginning, you will not like CutCon, I guarantee. And I show you why you won't like it. Let's say I would like to execute pre-upgrade fix-ups. This is from the command line upgrade, the fix-up script for all my containers. But I would not like to run this everywhere by myself, and I can't even run it in a multi-tenant environment by myself, because in a $seed, I can't run it. It's read-only. I'm not allowed to turn it read-write to run that script. But for that purpose, we have cutconpl. So cutconpl is the vehicle to run, operate scripts in a multi-tenant environment. And not only, you can also use it for non-CDBs, of course. It works as well, of course. But it's Perl. So you need to call Perl, and please make sure it's the Oracle Perl. And then you need to call cutcon in the second line here. Cutcon is in the RDBMS admin. So RDBMS admin is not in your path, so cutconpl won't be found typically unless you point to it, or unless you sit in RDBMS admin. But this is not a good idea. -n1 means only one worker. I have this intentionally on the slide because for whatever strange reason, this is still after, I don't know, 10 years, this is still not documented that that exists. But you can decide how many parallel workers you would like to have. -d, the directory, is mandatory. This is where is the script located I'd like to execute now. So where is my pre-upgrade fixup.sql located? -b is the base name of the log. For whatever strange reason, the tool doesn't decide it by itself. You have to define the base name. So my log will be called pre-upfix0, because only one worker.log, which is strange. And I recommend you deeply that you always use -l for log, because otherwise your logs will be always written into your current working directory, whether this is your Oracle home, or whether this is your RDBMS admin or your Oracle users directory, whatever. And all this fuss to execute only pre-upgrade fixups. Ooh, that's a lot. Why? Because it executes it now in the root container, in the seed, and in all PDBs. And this is the power of cutconpl. You can automate a lot of tasks because these things will be executed in all the pluggable databases as well. And this is why cutcon, it's a bit harsh to script it at the beginning, but after a while, I guarantee you'll like it. The PDB $seed, I told you it's read only by default. And if you need to change anything in the PDB $seed, and you will find this underscore in all our RDBMS admin scripts as well, it's called _Oracle script. And this is also, I think, not in the Oracle documentation, but you find a few traces in Moz notes. So Oracle script is used to allow actions in PDBs, and especially in the PDB $seed. But don't use it by yourself. I was at a customer a year ago, and the DBA smiled at me when I introduced this. Oh, Mike, we know already. We have put it in all our own scripts. And later on, I learned, this is a bad idea. And I show you why this is a bad idea. My example here, you set all the sessions that Oracle script true, then you create a table. And when you check in the dictionary later on, and you display the Oracle maintained flag, you see here from DBA objects, for my test table, the Oracle maintained flag gets to yes. This is a huge problem now, because when I upgrade the database, we do certain actions only on the basis sometimes that an object is Oracle maintained. For instance, they were auditing changes which happen only when the object is Oracle maintained. Now we would do changes also potentially to this table here during the upgrade, because the upgrade scripts check for that. And I just had a case with a customer where they had in all their own created stuff, Oracle maintained yes. And the question was, how can we get rid of that now? Because we have a problem. Houston, help us, please. So please don't do this. But be aware, in some cases, like changing the default password algorithm, you have to go into the PDB $seed, open it, read write. So you set Oracle script, and you can shut it down, open it, read write. It opens regularly. You change what needs to be changed, and then you shut it down and bring it back in read-only mode. That's the way how to deal with that. And this is something which is also in this My Oracle support note on the middle of the slide. You should not be invoked by users, but you can invoke it for some reasons. Now with 12.2, we changed something in the undo layout. Before 12.2, we had shared undo. So we had only one undo table space in the black brick here in the root container. Since 12.2, we have local undo, and this is also the default. So if you switch alter database local undo on. The downside is in an environment with not only one PDB, you have a bit more files now in addition on disk. But local undo is the requirement for a lot of features actually. So how do we create a PDB? When we create a PDB, we simply say create pluggable database. Then we have to specify an admin user. You will never use that admin user potentially ever again. But at the process, when I create that PDB, it gets provisioned as a clone from the seed. And as the seed has not any own users, only a super user, common user does that here, but the PDB $seed itself doesn't have any users. We need one user for this, like making things work. And this is the admin user. You can drop that later on. SAP, for instance, drops the admin user afterwards. The good thing is that PDB is ready within seconds. So not like the old days where you have to open a ticket and request a resource, and 2 days later somebody is kicking off a create database script. No, no, no. This PDB is ready within seconds, and you can load your data into it. If you wonder about the file name convert, I can give you a tip here. The file name convert string has a very simple pattern matching. So instead of saying /data/cdb1, PDB seed, blah, 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 and convert this to, I can only convert the differences in the base strings, like PDB seed to PDB1. This makes writing much easier. In ASM, you don't check, or in ASM, you don't care, because there everything is Oracle managed files and gives you much more pleasures anyways. When we do local cloning, so I create a local clone here. In this case, I simply say create PDB2 or whatever the name is from PDB1. Again, I convert the file names here because I'm in file system. In ASM, you wouldn't care. And I can specify also a higher parallel degree. By default, we take the CPU count. If you want to get higher, you can add parallel 8 and then have more operations. It's a bit harsh to monitor that in $session long ops with these two events, but this way you can, for like, if you do this for a 16 terabyte database, you would like to know where is it right now? Has it progressed everything? You find it in this $session long ops. The cloning works also remotely. If I want to remote clone, I need a database link from the black CDB2 into the red CDB1. And I'm logged into the black one here. And in the black one, I say create pluggable database PDB1 from PDB1 at dblink. And we use this database link to really copy over the PDB with all necessary, whatever we need to. So this way, remote cloning, that is also extremely helpful. And you can just spin up for a developer. Developer needs a pod. Can I test? Let's say it's a 100 gigabyte PDB in an hour. It's all done, or half an hour, whatever. It's there. Developer can work with that. And this is, I think, one of the biggest strengths of multi-tenant, this flexibility of just providing something. But a hot cloning, this was deeply missed in 12.1. In 12.1, you had to either disconnect all users or switch the PDB into read-only mode to clone it. Since 12.2, and this was one of the reasons why we needed local undo, you can do hot cloning. And the PDB, the source here on the left side, remains open the entire cloning operation. So when I start my clone now, we start reading from the left one and writing on the right side. And until this point here, we are all good. No issues. And there won't be any issues. But what happens typically is the further down we go the road, the more uncommitted blocks we have, which are like left behind. We copied this blue block here in the first line already, but it's of course not in my clone because I copied it earlier before it got changed. So after we go on, we have more and more of these blocks where we didn't catch them. So at the end here, I have an inconsistent clone. And in order to make the clone consistent, we do now the following. We age out the dirty reads, the dirty blocks, which are all marked here now with red X's. We age them, we correct them again by shipping the redo over this database link and applying the redo. So basically, we recover the PDB, or we do nothing else than in a data guard physical standby environment we would do. Just we make it now consistent. And the only thing we have to really clear out at this end is if we have uncommitted transactions, we need to apply rollback for these uncommitted transactions at the very end, and then it's done. And so this is second cool feature because that really works very, very well. I use this a ton of times. I know customers who use this all the time, and it's so easy. And this is a big step forward, actually, when you compare this to a regular environment. We can also relocate, and relocate means we create a pluggable database. So I'm logged into the black one again, and I create it now, but with relocate availability. So this means I have load, and the load is represented by this flame graph here in the slide. So I have load on my red one, and what we do is we quiesce it, and then over the database link, we relocate it. So we clone it, but as soon as the cloning process is finished and the redo has been applied and the uncommitted transaction have been cleared out, then the PDB gets removed from the source. And ideally, our load will be moved over. So for this to be possible, the regular database listener has been extended with scan listener functionality. So it got stuff from the rec listener. And if you need to set this up, please go to the documentation. Documentation tells you all the 3 different flavors, how to set up the listener correctly to deal with that. It works. I'm not such a big fan of that. I still prefer the cloning or refreshable clones because the fact that this PDB gets removed afterwards, that is a bit something where I see some room for potential not so going well things. The standard way for you will be you will upgrade and then you will plug in. And when you upgrade and plug in, you need to upgrade to the same version. So my first step is I set my database read-only after I upgraded it. So I upgraded, let's say, to 19.8. Now I set it read-only. And when it's read-only, I create this XML file. This is the first yellow box on the slide, exec dbms pdb describe. In this XML file is now describing the physical layout of my pluggable database, special parameters, SCN, data file header, stuff like that. Then I shut down this database and I log into my CDB. And in the CDB, I create now or plug it in by saying this is the second yellow box, create pluggable database PDB1 using the XML file. By default, no copy. That means the files stay where they are. And I think since 12.2 or 18, you don't even have to say temp file reuse anymore. But this is not the end of the story. So the PDB is now plugged in, but it's not assimilated yet. Like if you think of Star Trek, when Captain Picard became a Borg for a while, it's not that the Borg steal you from Enterprise. It's like you have to get all these attachments and really be assimilated in one of them. This happens with the non-CDB to PDB. This is the assimilation, the sanity script. And when you watch the output of it, it tells you what it does, and it does a hell of things because it really goes deep down in the dictionary. Just think of your PDB had a dictionary, and now it still keeps its dictionary, but a lot of things will be removed and exchanged with metadata links because the root container has the major dictionary and the PDB has just now a leftover dictionary, I would call it, with still some things left. But this, all that, as I showed you before, can be done with auto upgrade. But this non-CDB to PDB This is a script which runs only once in the life of a database, never again. It's only for the purpose of assimilating your non-CDB, making it a PDB. This is what the script name says, non-CDB to PDB. It's irreversible. So far, I'm not aware that anybody wrote a script PDB to non-CDB. That means when we have you, you're in, and there's no door to open to leave the universe of multitenant anymore. Since 12.2, luckily, that script is rerunnable, and the runtime really depends. And this is something I will come back later on as well again, because typical runtimes can be just 10 minutes, but we've seen also now with EBS databases, runtimes of 4 hours. So the script, I would say, is not really optimized, and there's a ton of invalid objects due to all these changes it does in the dictionary. So a lot of recompilation options happen here, and there's room for improvement. Another technique to migrate to multi-tenant, if you, especially, let's say you're on HPUX today, and you would like to go to Linux anyways and do all this in one pass. So you don't want to do upgrades. You just would like to take your database and plug it in on Linux, go cross NES. And for that purpose, we have full transportable export import. So you create a new PDB, and from this new PDB into your source database, which can be 11.203 or newer. So oldest release can be 11.203. We don't even allow upgrades from 11.203 to 19C directly, by the way. But in that feature, we can do this. Database link, then we set the table spaces in the source read-only, or if it's really big, you can even use incremental backups if you need to. And then we copy the data files or the incremental backups. And then we start data pump. And with data pump, we pull now all the necessary dictionary information over into this PDB. So you don't run an export. And in this case, you use full yes and transportable always. And if you talk to an 11 database, like I do in my verbal example here, then you have to set version 12 because you talk to the 11.2 data pump export secretly, even though you don't do an export and you don't write a dump file, but you talk to the export side. And we need to trigger that secret feature for 11.2. As soon as your source is 12.1 or newer, forget this version 12, you don't need that anymore. It works out of the box. This is a super cool and easy way to migrate directly into PDBs. You don't need to do any additional upgrades. You don't need to, the only thing you need to do is actually when your files are on a big engine like HP, you need a conversion of your files with Armin. That's the only extra thing. And another strength of multi-tenant is doing upgrades with multi-tenant. So when you go to the slides or on the blog, you find a case from a company in Switzerland called Mobiliar Insurance. And you will find that Mobiliar Insurance upgraded in December 735 PDBs in 5 CDBs, and they did the everything at once approach on the left side. So everything at once means you prepare a new home, you start auto upgrade, it upgrades all your PDBs, and a few hours later, everything is done. Bang. On the right side, you can have more control if you unplug, plug, and upgrade. In this case, you run only one upgrade in the black PDB at the end. Once you unplugged and plugged it back in, you can do this with several PDBs if you need to. You're not limited to only one. So on the right side, you have more control. On the left side, your outage is longer, but you have less work. So this is one of the cool features here, upgrade in multi-tenant. What we support with auto upgrade right now is the left side completely. The right side is coming soon. So we are almost there, actually. We do some tests, but the feature is, I think, more or less ready to go pretty soon. When we do the left side, everything at once, we upgrade always the root container first, and then we upgrade the PDBs in groups. And here your compute power decides. On the right side, we upgrade only in the PDB or the PDBs you unplugged and plugged. If you do this unplug of PDBs, there's one nice feature which is always overlooked, but I think it's quite helpful. You can unplug a PDB by saying alter pluggable database, PDB1, unplug into, and typically you would define now an XML. But if you don't say XML but .pdb, like marked in red here, it will create an archive. This takes, of course, a bit longer, and you have no influence on the archive compression algorithm here, but it's a zip file. So you can unzip it. And if you look into it, the good thing is, here in this case, I have system, sysaux, undo table space, not more in my PDB, it was just a test pod, but I have also the XML file. So everything is together, nothing is lost. Just be aware, there were issues with archives in 12.2.1 in ASM. And I had one customer who reported also a similar issue on Windows, which is bad because if you can't plug back in, or if a file is missing, that's not so cool. So if this is your technique, try this in test before. And if you're happy and everything works well, then you can use that in production as well. Another hint, and this is often also not seen, but it's really helpful, tiny little helpers, save the state of your PDB. Because there's nothing worse than you shut down your CDB, you bring it back up, and you have to start your 10 PDBs, either one after another, or you say all the pluggable database, all open, and then it takes a bit. So easy workaround, you say save state, and then you bring down your CDB, you bring it back up, and the PDB starts automatically. This is not necessary in a cluster environment, because in a cluster environment, you typically do this with the services. You could do it in a cluster environment, but it's not necessary there. And with discard state, you can remove this memory of the PDB about the state it should go into. Then when you look into every 12 database, doesn't matter if you have multitenant or not, you will have a new class of views and over 1,000 views starting with CDB underscore. And in addition, we have also views who don't follow that naming convention, but that's a different story. In the CDB views, it's like the super dictionary views now, because every PDB would give you, when you check DBA objects, it would give you only the objects in this PDB. But when you query in the root container CDB underscore objects, you see all the objects in all your pluggable databases. And in order to make this work, all the CDB views have one thing in common, and this is the column con underscore ID, the container ID. And if you don't have multi-tenant, you still have these CDB views. Check this, your con ID is always 0, because 0 basically means there's no multi-tenant around. There's no pluggable databases. But in a multi-tenant environment, when the con ID is 1, that means the object belongs to the root container. Con ID 2, it belongs to the seed. And I come to this fine print later on. I have a special slide for that, why you must set this underscore parameter in multi-tenant. And con ID 3 to 4,000, whatever, this is the con ID of a PDB. So this is how we differ to which PDB an object belongs. Then since 12.2, you can also mix character sets. The only requirement is that your CDB $root must be created with AL32 UTF-8. Be aware, that means all your provisioned PDBs, your provision will also have always AL32 UTF-8, but you can plug in now PDBs or non-CDBs with different character sets. And I think especially for us here in Europe, this is really important. And also for you, it may be really important because you are like serving customers from all over Europe or all over the world. So this can be really important. And this, in 12.2, we had some issues. I would recommend this mix of character sets with 18 or better with 19C. With 12.201 in the early days, we had some corruption issues at some of my customers with mixed character sets. That was not so cool. Only together with local undo. And local undo is also a requirement when you want to do flashback plugable database. Local undo is the default anyways, so it should work out of the box beginning with 12.2. All the sessions that container PDB1, create a restore point, guarantee flashback database, and then do something mean. Like, what happens if I do a truncate obj dollar? Let's see. Then shut on immediate. Don't do this on production, please. Flashback the pluggable database to the restore point, and then say all the pluggable database PDB1 open reset logs. Now, very important, this open reset logs is not really doing open reset logs. It doesn't reset your log files. And I had recently one customer who told me about a story where they had two restore points crossing each other, and they opened a PDB with reset locks and couldn't go back to the other restore point. And this is intended. So even though it doesn't really do a complete reset lock, something is happening in the PDB. So be a bit aware. But the feature is quite cool, and never forget to drop your restore point at the end when you are done with your tasks. Yeah, and this is one of my favorites, the lockdown profiles. The lockdown profiles actually came in with 12.2 as well. So the idea of a lockdown profile is that I can take away certain things or allow you only a few things which are not doable via the grant and role concept in Oracle. Because, for instance, I can't disallow you to set alter system set optimizer mode rule. That is not possible. I can take away the entire privileges to say you can or you can't do an alter system, but I can't restrict it to certain activities or features. And this is what lockdown profiles are doing. So in the example here, in the CDB, I create a lockdown profile. And with the lockdown profile, I disable for the alter session command set, alter session set, I disable everything except for optimizer mode or cursor sharing. So I allow you, as soon as I go now and apply the lockdown profile to my PDBs, alter system set PDB lockdown P1. So I apply, I make it active. I pull the trigger. And you, as a user now in the PDB, you try to set alter system set SQL trace. And then you get an error, insufficient privileges. Because I allowed you only with my lockdown profile to set optimizer mode or cursor sharing. So if you say, hey, set cursor sharing force, yeah, you can do that. And this is so powerful. Be aware with that. Don't overstretch it, because you can do really, really mean things. And when you open SRs and you have lockdown profiles, tell Oracle support about that. They need to know, because things can really act differently depending on your lockdown profiles. This is used in our cloud deployments because this ensures that you can't do certain things or just peek over the fence to your neighbor, say, oh, what is the neighbor doing? Yeah, this is really, with lockdown profiles, so heavily constrained. This is why they came in. Also be aware, if you start using multitenant really actively, like you start unplugging, plugging back and forth, in your 19 multitenant environments, your CDBs always should have compatible 1900. Never change that. Not when you create a fresh one, not when you patch, never adjust it. Have it 3 numbers. This is the database compatibility. 3 numbers is correct, not 4 like for ASM. 3 numbers are fine. And then you can unplug, plug. And I show you in the example why this is so dangerous. I have a CDB with compatible 12.2.0, and I unplug and plug into a 19C, and there's a silent compatible change happening. And you have no control on that. It just happens. That means if I would like to downgrade now, that's not possible anymore because the silent compatible change adjusted compatible. So be aware of that and make compatible equal in your environments. I had this once in my lab where I had 1900 and 1910, and I wanted to plug out from the 1910 back into the 1900. That's not possible. It tells you, no, compatible is lower than your source setting. Doesn't work. And downgrade works as it worked for regular databases as well. Here you do it manually. Auto upgrade doesn't do that for you. You run the cut downgrade script at first, then you unplug your PDB and you plug back into the source, which has the same compatibility, and then you run cut reload, and you must roll patches with data patch manually afterwards. So now we talked a lot about multi-tenant, but what if you want to migrate to multi-tenant? How does the fallback look like? I showed you some simple migration techniques already. And a high-level overview at front is either you upgrade to the matching version and then you plug in, as I showed you, or you migrate directly where you don't do an upgrade. Data pump is the easiest. Transportable table space is full transportable export import. Every approach requires sometimes significant downtime. It can be reduced with Golden Gate. And for me, this was a big hit when we said, hey, with 20C, it's just multi-tenant, because the proven fallback strategies don't work. I can't just go back to a restore point when I plugged in. I can't do a downgrade the regular way. So I can only export import. I can't even do transportable table spaces if I come from a lower release, because transportable table spaces works only same or higher release. I can, of course, use Golden Gate on top. So in case you are attempting that, I would highly recommend that you go to my blog and you start reading about database migration from non-CDB to PDB. Because I try to really, this is long blog posts, be prepared, you will read over an hour easily. Because I try to put together all the pitfalls, the different techniques, but also the pitfalls I see, just to help you avoiding that. And the typical pitfalls, the most likely one is a component mismatch. So your CDB doesn't have a component a PDB comes with. Different patch levels can be an issue. Non-CDB to PDB requires downtime, or simply that you find out, oh, auditing, I have now audit information, the PDBs as well. Or I need to turn on the AWR in a PDB if I want that. Or the standby implementation is different, and I show you that in a minute or in a few minutes, how that is different. So please, on the blog, you find a lot of information about that. I spent a long while trying to write up all these things. And in this blog post, you will find also your best friend several times. And I put the best really in quotation marks. The view PDB plugin violations. The first thing which struck me with that view is that it doesn't follow Oracle naming conventions. And it has so many underscores. So you're always with your hand like doing this. Ugh. So then you have to query it, because it's really strangely set up. You have to query for all this information in order to find out what's going wrong. So when you plug in a PDB, or when you do the compatibility check up front, which typically tells you no, it's not compatible, then this view gets populated. So here in this example, what do we see? We see a lot of errors, and I marked them in red, and it says the database option cut Java mismatch. The PDB installed, so it says in good English, hey, wait a bit, your PDB has cut Java installed, but the CDB doesn't have it. And this is not possible. So it's an error. You can plug in your PDB, but it will ever open only in restricted mode, never unrestricted, until you solve that. So errors must be solved. The problem I have with that view is that it accumulates over time. When you really see this view in a big custom environment, you have easily thousands of entries in it. And only if an entry is resolved, you can purge it since 18C. Everything else stays in forever. I think I filed a bug for this 6 years ago, and still there's no relief for that. So be aware, and it becomes your best friend, because you will have to deal with this view quite often. So when we want to migrate, the idea of migrating into a pluggable database is that we just skip any upgrades, and we can even do this often for versions which are not upgrade supported. So here in my example, I have an 11.203 database. I provision a new PDB and I migrate. I can migrate with data pump, with transportable table spaces, even with full transportable export import. And this is quite a charm here. No extra upgrades, go directly rebuild, or be like change things. Use a new way of compression, or get rid of lob files and stuff like that. If you do this with data pump, I think this is no rocket science. Everybody knows how to do it. So step one here, you provision a new PDB, then you exp.dp, copy your dump file, imp.dp, bang, that's it. But you can also do this over a database link. So you create a database link from the PDB into your non-CDB, and you pull the data over. Especially if you're on different SAN storages, this often is faster, because no dump file is written and you don't have to copy over a dump file. So you have to experiment sometimes. If you want to fall back from multi-tenant, then this is the typical fallback approach. You export from the PDB into a dump file, copy the dump file, you import into your old source version. You can't do this on database links, because or data pump over database link again works only same or higher version, but never lower version, unfortunately. The key trigger here is that you have to say version equals the format you would like to import to. So in my example, I would like to go from 19.9 to 11.204. So during export, I say version 11.204, and then it has the right format my 11.204 database understands when I import afterwards. Then I showed you the upgrade before. So we do an auto upgrade first, then we plug in, then we convert. With 20C, this will change. It has to change then, because with 20C also auto upgrade, or 21C, whatever the next on-prem release will be, auto upgrade can't upgrade first, because then you would have a non-CDB. That does not work anymore. So then auto upgrade needs also to plug in and then to upgrade. As long as we are allowed to do it a different way, this way on my slide, do it this way. It's the best way. Every other technique, I cover them on a blog as well, like plug in first, then do the upgrade, or use the non-CDB database link technique, lead to issues when you have an issue, because then you're plugged in already. For the upgrade, for the first step here, I have a proven fallback. Auto upgrade writes a guaranteed restore point. I can go back. As long as I'm on the red part of the slide here on the left side, I can always fall back. I can downgrade. But as soon as I enter stage 2, then there's no real way out there unless I use data pump or restore my backup. And this is why I'm not a fan of plugging in first, because then you lost this ability to fall back for the first stage. And a customer of mine in Spain recently plugged in with non-CDB directly, and they couldn't open the PDB unrestricted because they hit an issue which was not visible before. And then you sit there and you repeat the entire action again. So please, this is the best way. But how do you fall back? For the first part, as I told you, we can flash back to the guaranteed restore point, or we could downgrade. But once we are in multi-tenant, we can only ideally data pump export import and then put golden gate on top. There's no real like unplug and make me a non-CDB again. And I can't downgrade anymore. So in this case, I'm in and I have to stay in. Multi-tenant team promoted this alternative, which looks, when you see the slide, you think, oh my God, what's that? So I guide you, no worries. I intentionally didn't do this animated because sometimes the animations don't come out well on Zoom. The idea here is that I do my upgrade, and in upgrade, compatible stays constant. So we don't touch compatible. So let's say I have a 12.102 database and I upgrade it to 19.9 and compatible stays 12.102. So at this point, I could fall back with a guaranteed restore point. I could downgrade. But I plug in now. In the middle of the slide, I plug in step number 2 into my black CDB. This black CDB is 99 as well, but I created it intentionally with compatible 12.1.0. Works. Very important when you do this, no local undo. You need shared undo because local undo is a 12.2 feature. Later on, you will need extra downtime in order to be able to switch to local undo. Sorry for the noise in the background. My printer is just doing the weekly printer check. So be aware, you have to make sure you create it that way. Now we do the third step, non-CDB to PDB. Still the CDB is the same, no change here. And then if I need to fall back now, I have the yellow CDB prepared, which is a 12.102 CDB and has compatible also 12.102. So I can unplug now and plug back in. What would you get here? You would get a PDB. So you can't leave the universe of PDBs anymore. That's given, that's set. But you are back in 12.102. So I leave it to you if you say, yeah, this is really a good fallback alternative, or this is just like the exit of the exit when the exit failed. So I leave it to you. I have no experience with that in a custom environment so far, and you decide. But it's a possibility. I would call it a possibility. So the fallback for upgrades, move to multi-tenant, and this is important to understand, is always a migration. It's never just an upgrade, it is always a migration. And so the useful fallback techniques don't exist. No downgrade, no flashback. Only possible fallback options, data pump export import, Golden Gate, or the alternative I've shown you before. And now I would like to show you an example from the real world, because this shows you where you have to pay extra attention. And I had standby in ASM as an example before about how or where you need to take care on. And I would like to show you that. And this is a real world example because this is something I exercised with a future reference customer. It's a banking customer. And as soon as they give me go and say everything is a 19C, we'll have a very cool reference story here as well. Because we moved initially, this was the initial setup for one of their databases, and it was on Intel Solaris. So we didn't even just go from 12102 to 19C. We moved also from non-multi-tenant to multi-tenant, and we moved from Intel Solaris to Linux. Intel Solaris is a little ambient platform like Linux, so it's not so complicated. And since 11204, you can build up a physical standby between Linux and Intel Solaris to move over. Production database here is the red one, 12102 database, 10 terabytes in size. It's a banking system, and it runs if maximum protection mode. So maximum protection means when I do a commit on the red side, the commit is sent over to the standby, but the standby has to acknowledge and give back an acknowledge to the production side that a commit has been written on a standby. Until that is not there, the production can't go on. So I need a stable, a very good network. I need a very reliable with low latency network in order to make this really work well. Often such customers have not only one standby and make themselves dependent, but also two standbys or a FarSync standby to make sure things are operating well. We are at 100 kilometer distance approximately. And when we do now this change to multi-tenant, the thing we would like to avoid by all means is that once the red side is a 19C multi-tenant database, a PDB, we don't want to recreate a standby, because that would mean we would have to ship 10 terabytes over 100 kilometer distance and get an additional day outage potentially, or even more, simply for the fact we can't go live in production when the standby is not in place, because we run maximum protection. This is essential here. So the goal is we upgrade and we plug in, but we repeat the same steps automatically on the standby. And while it sounds super simple, there are a few implications. So let's start with the first step here. We have downtime. It's data guard environment. So we disable the broker, we defer the log transport. I defer the log transport to be on the extra safe side. You don't have to necessarily, but you must disable the broker. Then I upgrade my database from 12102 to 19C. Standard. Now I enable the log transport, enable the broker, and I start my standby, the yellow one, in my example here, 19.7 home. And then it gets the redo from the production, and it gets upgraded simply by redo apply. A few minutes later, everything is good, everything is in sync again. So, okay, so far so good. This is standard, has nothing to do with multi-tenant yet, nothing to do with ASM. It's just a standard when you upgrade normal database with a standby in place. So now we have the set here on top of the slide. 19.7 production, 19.7 standby. But in addition, I create now CDBs. The CDB for production, the black one, and I create with ARM and duplicate for standby, I create the standby part on the standby side. So my production and my standby servers have now two databases. They have the regular one, non-CDB, and they have the CDBs. In addition, I set in Aura parameters like the standby PDB source file DB link, and you will see why this is so important. Now in the read-only phase, I create this XML file. And once I have the XML file, I need to do something in addition because I'm in ASM here. And this introduces a new thing. When I'm in file system, I can create my standby exactly from the file system layout as it is in production. But when I'm in ASM, I have Oracle managed files. So my system table space file on production has a different name than a system table space file on a standby. And so for ASM and OMF, I need to create an ASM alias list. And I show you on the last slide here of this walkthrough a node which explains you how it is a script inside how to create this ASM alias list. This file I need to bring to my standby and I need to execute it in ASM. And the purpose for this is, if I would plug in now, and let's say my system table space is system dot blah, 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 long, how like OMF files look like, it would try to plug in exactly the same file on the standby side, which of course does not exist. So I need to tell the standby like a translation table. And with the translation table, it works afterwards. So this is now executed on the standby. I can then plug in on production. And then I run non-cdb to pdb.sql runtime varies as I explained before. Okay, so production is good, it's in shape, upgraded, plugged in. Now I need this replicated to the standby side. So production is good to go, but now we enable a log transport and we let the commands come over, and then the plugin happens on the standby side as well. And this extra init aura parameter I showed you before is necessary that this plugin operation gets replicated to the standby side as well. Otherwise, it wouldn't replicate it. So we need to tell the environment, this happened on production, you replicate this please on a standby, and then the plugin works and everything will be replayed. So the entire non-CDB to PDB steps will be replayed here. And this way, I avoided copying my database again over the network. But it's not trivial. It's extra steps and mission is accomplished. And because this is not trivial, I had asked my friend and colleague, Peter van Poimbroek. So Peter is the DataGuard product manager, and you may know him because we were together in Slovenia, I think 2 years ago, both presenting at the user group conference there. And Peter's a great guy. When I called him, because my customer ran into an issue with 18C, and it turned out they ran into an Oracle bug with 18C. Peter, over the weekend, set up the entire environment by himself and replayed it with 19C and wrote an awesome blog post explaining how to do that in ASM. And this MOS node is very important because this MOS node here has also the steps when you do this with a standby in place. In ASM, it has these extra scripts to generate the translation tables for the file names here. One tiny little feature at the end here I would love to show you because I love this feature. It's so good. And I think it's the most underrated feature in multi-tenant. I have a 12.201 multi-tenant environment already. And we have a technique called the refreshable PDBs. And the refreshable PDBs allow me now, I create a new CDB in my new environment already. And I create a clone, but not a regular clone. I create it as a refreshable clone. So I get a 12.201 refreshable clone in my 19C environment. The good thing is I can push the button and refresh this over and over and over again. So I can do this again and again, as often as I need to. So I determine the point of synchronization. And on the slide, I say it's for upgrade testing, because what I can do now is I can upgrade the PDB and test with it. Please, this is not meant only for upgrade testing. You can do this as a technique every day. And you can do this also not only for testing, but also for live upgrades. So when the day of the days is coming, you can do this as your live upgrade as well. And this is super cool. I like that a lot. And it's so extremely helpful because you don't wait for your PDB to be cloned. You clone it. Doesn't matter if it takes 1 hour, 6 hours, no worries. You clone and then you refresh afterwards. And the refresh is very fast. So you avoid basically the downtime for the cloning operation, for the testing here, or also later for the live. So this is pretty neat. I like that a lot, and I used it a lot. So I blogged about it, upgrade refreshable PDBs, and it's not only for upgrade testing. You determine the synchronization point, and I think it's the most underrated, underestimated multi-tenant feature. So a summary, be aware, every migration is an architectural change. And this is why you don't introduce it from today to tomorrow easily. Every migration requires downtime. You can reduce the downtime. I didn't show that in the slides, but yesterday we had a virtual seminar where we showed all migration techniques and also incremental backups. So this should be available on the blog pretty soon. You can reduce the downtime with ink backups or of course with Golden Gate, but as we all know, Golden Gate has a license cost involved as well. Yeah, and a few, initially I called this secrets, but not everything here is a secret. So it's not secret. I would like to give you some additional hints at the very end of this presentation. And one thing I highly recommend you, and I have included this on purpose here in the slide deck, because this My Oracle support note describes a few very terrible, really terrible performance issues, which started with 12.201 and go on until 19C, and I'm pretty sure they go on further as well down the road. The reason for these issues was that a parameter I had never heard of before, cursor obsolete threshold, was set to the maximum of its value, 8,192, so over 8,000. This came in for the multi-tenants project of 4,000 PDBs. The default is 1024 in older releases of Oracle. The recommendation to avoid performance issues is in all your 12.201, 18, 19 databases, always, everywhere, set this parameter to 1024 to avoid problems. I put this in here because in the MOS note, it says you should do this for non-CDBs. I give you a clear recommendation. You do this for your CDBs as well, because we have seen optimizer problems. We have seen several issues already with this high setting, even in multi-tenant environments. So set this to the old default 1024. And please don't ask me the question afterwards, why, when we know this is an issue, why we don't reset it by default. I won't tell you. The other one, and I told you I will say a few words about this at the very end of the presentation, exclude seed CDB view. So this was a regular parameter without the underscore at the beginning in 12.1. And for whatever strange reason, the multi-tenant team has made it an underscore in 12.2 and sets it always to true by default. That means you query a CDB view and you don't see the objects belonging to the seed with the con ID 2. Now you would say, oh, why should I care? I tell you why you care. I had this twice already, that customers patched. And when you run data patch, you assume that all the changes go not only in the root, but also in the PDB $seed and all your PDBs. Both customers had scripts to check whether the patch execution of data patch was run successfully. And both had the default exclude CDB view false. That means true. Default is true. That means you don't see the objects in container ID 2. So both customers missed that the SQL patching in the seed had failed for various reasons. Doesn't matter here. Both ran into issues because as it failed, you provision a PDB later on, which is a clone of the seed, and you provision something which is not correct. And this is why I'm a complete opponent to the idea of hiding anything. When you get me a new system, an operating system, the first thing I turn off is this idea of hiding file extensions or hiding system files. I'm an adult. I know what things are meant for, and please don't hide anything. And this is hiding stuff intentionally. So please, recommendation, set this always in all your multi-tenant environments to false or make it a standard. Cool thing, with auto upgrade, you can pass on parameters during or after the upgrade easily. and you can pass on these two quite easily, and it will be in all your environments then. So I told you on the blog, I wrote a lot. So this is the starting point. Database migration from non-CDB to PDB, the overview where I explain the different techniques. And then I have all these blog posts about different techniques, things to know. So you find a lot of information, and hopefully this is helpful to you. Now, finally, let me quote here Alain Fourer. So Alain Fourer is the head of IT database services at Mobiliar Insurance in Switzerland. And this is, I think, or I guess, it's our most important reference for multi-tenant globally. So Mobi is now on Exadata. They use also in memory, but they started really early to moving to multi-tenant already with 12.1. And the story is quite neat because multi-tenant was an experiment. The developers complained that it takes so long to provision a new environment. They had a service level agreement of if you need a new environment, you open a ticket, it takes like 2 days or whatever until you get it. So as an experiment, they built up a multi-tenant environment, put an Apex application at the beginning into it. Today, it's their own database as a service application, and developers could provision their own environments easily. So they liked it so much that it became production. They put microservices in PDBs. And over a while, we went to 12.2, then we went to Exadata. And in December, we migrated 735 databases to 19C, so upgraded actually. And the task was mostly relatively relaxed. So start auto upgrade, monitor the progress from time to time, and there's no need to sit in front of the screen. So if you are interested in more details, our multi-tenant deck, also the webinar on the blog, has all the customer details, who the customer exactly is, the different steps from consolidating, moving to Exadata, upgrading to 19C, also runtimes and stuff like that. And they are completely 100% consolidated since 1st of October 2019. So for a year now and a bit, completely consolidated on multi-tenant with at the moment 2,100 and a bit PDBs. So it is an awesome success. So look in the slides. Finally, blog. This is where you can access the slides. And I had one question in the Q&A so far. If you have any questions, feel free. Otherwise, I think I'm still staying on time